Okay, so everybody can hear me? We're good online? So I'm going to ask you guys if you remember sociology class. Do you remember economics class? Did you learn about tragedy of the commons? Does anybody remember this? I hear yes. Oh man, I'm going to put you on the spot. I'm a professor. I got to do it.
Isn't it when you have a shared resource that has no rules on usage and then everybody destroys it because they overuse it?
Exactly. So the tragedy of the commons occurs when individuals have unfettered access to a resource, a public resource, right? And there are no formal rules, like no laws. There's no societal penalty you'll pay for being a hog, right, to regulate your usage. So what happens? Well, just like these guys sitting in their cars in traffic, wishing that others would have taken the bus, right? Individuals act in their own self-interest, right? What does that mean? Well, it leads to the accelerated depletion of that shared resource, right? So at this point, you must be thinking, what the hell is this guy doing at Garrett User Summit talking about such a broad topic, right? What does any of this have to do with Garrett Code Review? And hopefully by the end of the talk, you will agree with me that it has everything to do with code review and CI/CD resources. So I'm going to tell you a little bit about a research paper that we wrote on how developers are using CI/CD resources. This is on behalf of the rest of the research team. The first author was one of the postdocs, one of the trainees in my research lab, and the others are collaborators. I direct a research lab called the Software Rebels. We do the coolest stuff in software engineering. And I'm Shane McIntosh from the University of Waterloo in Canada. So let's start with a little bit of a story about code review. So I'm kind of preaching to the choir. Everybody here knows what code review is, but it's a key step in many modern software integration processes, right? Where this handsome, young, intelligent professor has generated an amazing piece of code. He's going to upload it to a code review platform. For the purposes of today, we'll talk only about Garrett, right? Because it's the best one. Am I right? Am I right? Okay, I'm right. Good. And Garrett would allow other, maybe less handsome and less intelligent experts comment on my changes and provide feedback. But it also allows automated tools to interact with my change, right? So maybe a CI/CD bot, static analysis tool we saw this morning, an AI bot, right, can provide some sorts of feedback to me as well. And I'll act on that feedback, we'll iterate until we're happy and I can integrate my changes, right? What I'd like to focus on today is this little guy and what happens if this little guy is unreliable, right? And why might that happen? Well, let's say this guy is performing builds, automated builds, right? So he would grab from the code base or from Garrett some version of the code, and he would run his analysis, and he would give me some kind of pass-fail signal, right? This code doesn't work. But sometimes these bots, if you give them the exact same inputs and you ask them to run again, they'll give you a different output, right? And we call this in academia, we call it a non-deterministic build. You guys in industry call it flaky, right? I don't know which one is better. I'm just saying. I've noticed there are two terms for this, okay? And flakiness has various root causes, right? Sometimes it's caused by the environment, right? So let's say that during that build, you were making some kind of network call, to an external API, and that thing happened to be down, right? So these kinds of service outages can cause flakiness. It can be caused by the test code itself. So sometimes tests have dependencies between each other that aren't documented. And if you happen to run them in parallel, well, you get flaky results, right? Sometimes it can be caused by the code under test. I was talking earlier this week with some people about retry storms. So sometimes the retry settings that you have tuned to a certain amount of time can be kind of close to the threshold when you would get a response. And if that happens, then you get lots of retries happening, and it can bring down services. So your code is actually at fault for the flaky behavior of the system, right? So in the context of code review, what happens if this bot is flaky? Well, sometimes these guys are voting on whether or not my patch can be merged or not, right? So if this guy comes along and says, you know, my checks didn't work, well, your author is going to be frustrated, right? I can't merge, I can't move forward with my change, right? So I don't know when this feature was rolled out, but there is a feature of Garrett and many other code reviewing platforms where if we don't believe this bot, we can ask it to run its stuff again without changing the code. We can issue a recheck request, right? And this recheck request, you know, assuming this intelligent guy really believes in his code and it's not his fault, maybe this would make our build pass, right? And then I would be able to merge my change, right? So we've now set the context, and I'm going to bring you back to this economics and sociology idea of the tragedy of the commons, right? So what could go wrong? We have this amazing recheck feature that allows me to rerun the build when things go wrong, right? Well, developers have unfettered access to rechecks. CI/CD resources are not free, believe it or not. And there are no societal or formal rules that control rechecks. Developers aren't signing the checks that pay for CI/CD resources, so effectively it looks like it's free. So what do we think is going to happen? Well, I'm kind of glossing over something. So deep in the documentation of OpenStack, there is a quote. So there should be some kind of societal penalty that developers are paying if they abuse rechecks. So they say you will be tempted to just recheck the patch to see if it fails, but please don't do that, right? So they're saying, like in our testing guidelines, we don't want you just spamming recheck because CI test resources are a very scarce resource and becoming more so all the time. So please be extremely sparing when using this resource. How many developers do you know who would read this document and change their behavior? Zero. Okay, I see some zeros. Yeah, and I agree. So let's see. We're going to talk about this as the tragedy of the rechecks, okay? And what we did is an empirical study, so that just means that we looked at real data from a real system to see how they're using rechecks. And we looked at it from three perspectives. So broadly speaking, we looked at the prevalence of rechecks. So how often when a test fails, do OpenStack developers punch that recheck button, right? We looked at how effective rechecks are as a fix for failing builds, right? So it could be a very effective way of getting failing builds to pass if, you know, you just punch one recheck and it changes the outcome, right? Or something else could be happening. And then we looked at how much it's actually costing from two perspectives, like in terms of dollars, because CI resources can be equated to dollars now, thanks to CI services like GitHub Actions and Circle CI. They put a price on minutes on CI services. And also, like, we looked at it from the perspective of developer time. So is recheck actually wasting more time than it's saving? And like I said, we did a study of OpenStack. So it includes over 66,000 change sets and 267,000 patch sets, so revisions, right? So lots and lots of data. And we also surveyed 24 kind of senior members of the OpenStack community to get their insights about rechecks and how they use it in their day-to-day lives. So let's talk about prevalence first. Okay. So I'm going to be showing you at the bottom of these slides from time to time this set of 24 heads. Okay. They're kept in the same order so you can see different people's behaviors. When they're blue, it means that they agree with our observation. When they're white, it means they disagree. I believe every time I've done a study of developers, there are a handful who will disagree with everything that I say. And you will watch for these three in the rest of the slides, okay? So the first thing we found is that, I'm phrasing this as kindly as possible, rechecks are quite popular. They're a very popular feature. 55% of change sets with a failing job invoke at least one recheck. So this means more than half of the time when the build fails, developers are not thinking, it must be my code. They're thinking, no, it's your freaking test, run it again. And we'll see how effective that is later. And if you do it at the patch set level, about a quarter of the patch sets with a failing job have a recheck being punched. So a popular feature. Now, it's possible for people to do more than one recheck, right? So this distribution is showing like how many patch sets have how many rechecks on them. I'll point out some distribution numbers here. So a median of one recheck, which means that at least 50% of the patch sets that do a recheck only do it once. A mean of 2 rechecks, and a maximum of, anybody want to guess? 23. Well, actually, it's 226. Yeah. Manually clicking rechecks. So, you know, a little bit like this guy, right? Just spamming the recheck button like it. Right. So when we talk about prevalence, I think it's safe to say that rechecks are commonplace. Like, they happen quite a lot. And it's a popular feature for developers in the OpenStack community to use, right? So next, let's turn our attention to effectiveness. Is this spamming of rechecks an actually effective way of getting failing tests to pass, right? Now, for this, we have several patterns that I want us to consider, okay? Let's consider this first pattern where the bot failed on the first attempt, and we do one recheck, and the bot passes. This is the perfect world where you spent the minimum amount to get the failing test to pass. There's also examples that we discovered where there were 2 bots that were failing on a first patch set. The recheck was specific to one bot, and that bot passed after one attempted recheck. And that one bot was enough to clear the vote to merge their patch. I don't know why. I'm not enough of an expert of OpenStack to understand the internals of this behavior, but we call these 2 kind of like, well done, good recheck, right? Not wasteful. There are some other patterns though, and we'll work our way through them. But first, I want to point out that about 9,000 of the patch sets we studied are falling into this kind of good recheck area, okay? There's another 2 types of rechecks where they've done the same thing. Effectively, at the end of the recheck chain, the bots are passing to clear the merge signal, right? But they've done more than one recheck along the way. And that's generating waste. That's the trash bin icons here. And these two are mirror images of the top two, right? And what we're observing here is that about 6,500 patch sets are in this more wasteful, but still successful recheck pattern, right? And at the bottom here, we have kind of two ugly patterns. Ones that they do a recheck and the build still fails, or they do many rechecks and still they can't clear the voting requirement to merge their patch. And there were quite a lot of patch sets here. So just the first case where they've done one recheck and it failed, again, is about 12,000 patches. So that's, you know, close to already competing with the two previous successful cases. And this one was another 9,200, right? So there's plenty of room for growth in the way that we're using rechecks. Okay, now what we found is that fewer than half of rechecks are actually changing the build outcome. Okay, only a quarter of them change it after one attempt. So that means you have to spam a little bit. And 58% of recheck chains never change the outcome. So it's still failing at the end, right? So is this effective? I don't know. It's an unlikely way to get your tests to pass, is what I would conclude. Next, let's talk about dollars and cents, because you guys are all captains of industry, and that's what you care about, right? It's all about the Benjamin. So this is my Neil deGrasse Tyson slide. Neil deGrasse Tyson likes to use these metaphors to equate things so that you can kind of put into your mind how certain physics phenomena work. So what we found is that 187 compute years, not minutes, not hours, not days, years, were spent on wasteful rechecks. So just the stuff that never passes, right? This is Jonathan. Jonathan the tortoise is 191 years old today. So we're competing with Jonathan in terms of how much waste we're generating with this. And if you do the back of the envelope calculation for how much this waste is costing, it's already in the millions for OpenStack alone, right? So if you used a commodity CI service like GitHub Actions or something like that, it will cost you millions. What we're showing you here is the cost for developers, like how much time is wasted by these rechecks. And what we show here are change sets at the top in green without rechecks. How long does it take in terms of the duration of the review? And this is a logarithmic scale. So, 10 to the power of 0, we're at 1, we're at 100, so on, right? Okay. What we're showing you here is that if you don't do recheck, your patches get reviewed a lot faster, right? And I don't know how many of you are accustomed to reading box plots, these kinds of things, but the line in the middle of the box is the median of that distribution. The two ends are kind of the 25th and 75th percentiles, and the extended points go out to almost the edges, kind of like the 95% confidence area, right? So that box is a lot farther that way than this box, which is closer to this, right? So if you don't do rechecks, your reviews kind of go faster. And this is kind of natural and a self-fulfilling prophecy, because when we talked to the OpenStack developers, one of the things they mentioned is that as a core reviewer, if I see somebody spamming recheck, I'm not going to prioritize that review. I'm going to wait until they settle down, and I'll come back and I'll take a look, right? So in terms of cost, we have two kind of takeaway messages, right? They waste time and they're wasting money, right? Now, I think this is the part where I hope you guys are interested, and you agree that recheck waste is a potential problem, right? And I think that from the people I've talked to over the last time since this paper was published, they all kind of agree it's a problem, but they don't know what to do about it. Because developer time is also useful, right? And a flaky build is hard to fix. Reproducible builds are not easy. So what we've proposed in our current ongoing work, still under peer review, I can't talk to you too much about it, but essentially we inject a statistical or a machine learning model in between when you hit the recheck button and when we actually run it. So our hypothesis is that there's a large percentage of this recheck waste that we can just stop by saying, are you sure? This model says it's 99% likely that your recheck is not going to change the outcome, right? What I'm showing you here on this plot is the threshold we set for how certain the model needs to be before we react to its feedback, right? And here on the y-axis is the value. So we've plotted two kinds of importance metrics, right? So as you move along here, you're adjusting the dial for the model, right? And as you set the threshold higher, you are setting the certainty lower. And this line here shows you of all the wasteful rechecks, how many did I catch, right? So as I increase the threshold, I catch more of these rechecks, right? But as I increase the threshold, I'm also harming how accurate these suggestions are. So sometimes I say, don't run a recheck when you should have run it, right? So this dashed line at the top shows the percentage of times when we said you should skip that we were actually correct, right? So some people go bungee jumping on the weekend, and others look both ways before they cross the street like 3 times, right? So this model works for both extremes of people, okay? And we picked kind of 2 configurations to show that, right? So the first is, if you set the threshold to 20, you're going to catch about 33% of the waste, and you'll be correctly skipping 88% of the time. So that's pretty good for your conservative person. And then for your more risk-taking person, you could set the threshold to something like 0.7, where you're going to catch 99% of the waste, but you're going to be incorrectly skipping 33% of the time, right? And of course, you can tune it anywhere in between, right? Yeah. So I present to you that because I am here, and to academics, you guys all just look like giant money bags, and I'm here to hopefully collect some money from you to go back and feed my hungry graduate students. But I honestly believe that industry and academia working together is really powerful stuff. It can generate profits, sure, but I think that giving my graduate students access to like real contexts is a powerful way to train the next generation of highly qualified personnel. That's what the Canadian government likes to call them. So I need to do a little bit of bragging to get you guys excited, right? So I've worked with a bunch of different companies, some in the video game industry, some in the more traditional legacy software industry, some startups, large corporations. I'm hoping that we can add your organization here and we can continue to build cool solutions together. What do collaborative projects provide for the industry folks who want to generate value? Well, it provides you with graduate student trainees. So if you have a unique kind of CI/CD code review problem, graduate students learning about the latest and greatest research that you might be able to apply to your context would be a really powerful way to get that done. We've built prototype tools like the one I was just telling you about that will skip rechecks that are wasting millions of dollars, right? We work on proofs of concept. So sometimes you have an interesting idea in your company setting, but you guys cost a lot of money, right? You don't have the engineering hours to pay for somebody to go and try and POC things. A graduate student costs pennies on the dollar, They eat ramen noodles, right? And I've been told that this is the feature I should have been pitching first, is that when I collaborate with an industry partner, you get me on speed dial. And these guys are calling me all the time to say, oh, we heard about the latest AI model, or we heard about this. Can you explain it to our teams? And I'm happy to do it as long as you keep my graduate students fed. Let's use a real concrete example to show you how we've worked with some industry partners in the past. This is a very popular video game that you've played. If not you, your kids or your nephews or your nieces, what have you, have played it, okay? It's developed by Ubisoft. Maybe that name is not so popular in the video game industry these days because they had a recent release that didn't go so well. But I promise they're doing great stuff. What we did for them is we developed a technology to extract from their video games this dependency graph and then use like the changes that are incoming for CI/CD requests as queries on the graph. And then from that query, we can estimate, like, is this build going to break or not? And from that, we can skip unnecessary builds. Like if we predict a build is going to pass, we'll skip it. If we think it's going to fail, we won't. And we call it Raven build. The student likes ravens. And we've deployed this at Ubisoft, and it's saved them 280 build hours so far. So pretty cool stuff. And we've done lots of little things like this. So if you're interested, maybe I will propose it as an unconference topic for tomorrow. If it's not too self-serving, if you want to talk to me about potential collaboration opportunities, I'd be more than happy to do so. So just to wrap up, we've been talking about this recheck phenomenon, where this developer might have been blocked from making their submissions due to an unreliable bot, and we had this recheck feature that we could use to unblock them, right? We talked about how the tragedy of the commons is potential here, right? Because developers have unfettered access to rechecks, and there are no formal or societal norms dictating how they use rechecks. Then I pitched to you that I don't think that this is the best solution for the unblocking problem because it's generating a ton of waste, right? We saw that 55% of change sets invoked at least one recheck. We saw that 58% of recheck chains never pass, so they're not effective. And we saw that change sets we saw that rechecks cost millions, and that change sets with rechecks take a median of 22 times longer to be reviewed. If you are interested and want to read the paper, I have generated for you a nice little URL that will take you right to the paper. And if you want to connect with me, that's my email address. I'm on LinkedIn and other social media platforms. Happy to take questions. Thanks. Yes, that's how we're doing things. How do I get to it without destroying this beautiful slide that I just built for you? Yeah. Well, why don't you? Yeah. If you don't mind.
Hello? Yeah, okay. Okay, so Danny asked, where is the data coming from?
From the OpenStack community. Yeah. So in the paper, you'll find a replication package that so that you don't have to crawl all of OpenStack's Garrett data like we did. You can just download that data set. Yeah, yeah. We used your amazing Garrett REST APIs to crawl all of the Garrett activity that happened in OpenStack over the last few years.
And then do you think other open source or corporate communities have similar usage of recheck as OpenStack? Or could there be something specific to OpenStack CI driving their recheck behavior?
I think that both of those are correct. I think that there's something specific about OpenStack's behavior because I think they're more prone to flaky tests than potentially other settings, right? They're testing this large infrastructure, lots of microservices that communicate with each other, and there's timing issues with their tests from time to time. Now, that being said, I don't think they're the only system in the world that has this problem. And I also think that there's something at the core of being a developer that says, my code is great, couldn't be my code, I'm going to punch the button. I don't have scientific evidence for that, but I believe that as a developer, I would have been doing that.
Have you tried putting in place any regulation somehow in this context and see if it has any effect?
Like creating an OpenStack law that says thou shalt only recheck this many times?
I was thinking, I don't know, making developer paying for it. As in, say you have like free credit a day to hit a recheck. Is that, I don't know if you ever thought about that, or like is something that you tried? Could it be a good enough deterrent, press the recheck?
Yeah, so I present this as part of my class on DevOps, like fourth year undergraduate students. And one of the exercises we do in class is to brainstorm how we can stop the tragedy of the rechecks. And this is one of the common things. And almost everybody in the class like punches that guy. Who brought it up? Like the last time they said, we can dock the pay of the person who's spamming the rechecks, right? Yeah, I don't think that's a popular policy, but I think it would be effective. Yeah. Yeah.
Another question. So I'm one of the recheck presser, but usually what I do, I don't just press it blindly. I do a kind of assessment, right?
Mm-hmm.
So could be just checking the logs of the CI, which would be a good assessment, or maybe other kind of assessment. I think that might be worth doing. Do you have any study in that direction, or for now you just recheck, or let's say the Boolean basically value, so recheck or not?
We were thinking that would be really cool to see, like how many developers are being like careful and actually following the guidelines when they hit the recheck button. The problem is that we're going by traces that are stored in Garrett, and the best I could come up with is like the people that hit recheck too fast, like that they couldn't have thought of it, right? Like the build finished at 8 o'clock and at 8:01 they're hitting recheck, right? Like you couldn't have ingested that build log in that amount of time, right? But yeah, we're playing with heuristics, right? Like now it becomes a question of where the threshold is for enough time to ingest the build log. But yeah, another alternative would be like a treatment today, right? So we work with an organization to see, okay, like every time you press recheck, you need to fill in some kind of report that we would aggregate, right? Like why did you hit recheck? Is it because you have like some bias against a particular bot? Like that bot's always flaking, so I'm gonna just recheck without thinking, right? Yeah, but those studies are slow and take buy-in. You guys are here. It would be great to do a study like that in the future, though. Yeah.
One of your first slides, you kind of said the 3 main reasons why people think things are buggy, right? Do I remember that the bot was a? Oh, sorry. Why the bot was buggy? Remember you said it was like environment, test case, and what was the third one again? There's
the
3.
code itself, the code under test, could be just prone to having flakiness because of the way it's written.
I work at Qualcomm. We work on hardware. Sometimes hardware inherently can be flaky, can be buggy. There could be race conditions.
Right.
Of those 3 criteria, where would you categorize that type of behavior in those 3?
Yeah, maybe it fits under environment, like the environment that it's running in, but maybe it's also something more specific, right?
Because I'm just wondering whether a user would be rechecking more frequently because they inherently don't trust the environment that they're running on just because of what it is. And I wonder if that would increase the, prevalence of those rechecks being run.
Mhm.
So,
yeah, and developers kind of have some kind of connection to their context, right? Like I was saying, I was giving this example of the developer who says, "Oh, that bot, I know that bot always flakes. So without even thinking about it, I'm going to hit the recheck button because it's not even worth my time to think about it," right? And maybe that's a piece of the context here as well, right? Like that test that failed is one that's sensitive to the hardware context. And rather than me thinking about it, it's probably cheaper for the organization if I hit the button, right? Otherwise, thanks everyone.